Okay, so let's just review idea of functions. So we say that, let's take an example. Let's say f of x is a function. It's equal to x squared. This means that, for example, if we ask what's f of 2, it's 2 squared. If we ask f of 3, that's 3 squared. If we ask f of negative 1, that's negative 1 squared. If we ask what's f of a, that means it's a squared. And normally for our class, we are assuming that the inputs are real numbers. That means that we're not talking about what we call imaginary numbers. For example, the square root of negative 1 or the square root of negative 4, things like that. So those kinds of numbers we're not considering as inputs, real numbers. So just as a quick review, we talk about there are various sets of numbers. So maybe the simplest set of numbers is the natural numbers, and those are the numbers that are 1, 2, 3, 4, 5. Actually, I forget but I'll just assume that it doesn't include 0. So these are called the natural numbers. They're also called the counting numbers, and usually they're denoted with a capital N, so I can't draw very well. And then the next set of numbers we have are the integers, and those include the negative numbers as well, and I guess also 0. So 0, 1, 2, 3, and so on, but also negative 1, negative 2, negative 3, and on. So these are called integers, and they are denoted by z, like that. And then we also have the rational numbers, and those are the numbers like, so for example, one more piece of notation, going back to the natural numbers. The natural numbers, we use this symbol to mean is an element of. So we would say like 3 is an element of the natural numbers. We would say that 8 is an element of the natural numbers. Okay? However, for example, negative 2 is not an element of the natural numbers. Okay? So we have this symbol to mean an element of the set. And by the way, we're talking about, we use the notation of sets. So we use this kind of bracket. I'll try that again. We use this kind of bracket to indicate sets, and that's what I did. These are called the elements of the set, and these are called the elements of this set. So we wrote that 3 is an element of the natural numbers. We wrote that 8 is an element of the natural numbers. We wrote that negative 2, however, is not an element of the natural numbers. On the other hand, we would say that negative 2 is an element of z. Okay? The next set of numbers is the rational numbers. The rational numbers, that comes from the word ratio. And so we're talking about things like 2 over 3 is a rational number, or 3 over 2, or 9 over 7, or negative 9 over 7. Those are called rational numbers. So we mean anything of the form a over b, or anything that can be written in this form where a and b come from z. So this a has to be in z, and this b has to be in z. Then we call that a rational number, and anything that can be expressed like that is called a rational number. So for example, 1.5 can be expressed as 3 over 2, and both 3 and 2 come from z. So 1.5 is called a rational number. And then like 6 is a rational number because it can be expressed as 6 over 1. So any of these numbers are rational. Okay? So we say 6 is equal to 6 over 1. Both 6 and 1 are in z. So 6 is also a rational number. So the symbol for rational number is the symbol Q. Okay? So that comes from the word quotient. Okay? So quotient is also another word for ratio. Ratio and quotient mean the same thing. So anyway, we use this for the rational numbers. So we could say 1.5 is in Q. We could say 6 is also in Q. We already said things like 2 is in the natural numbers, and we also said that -3 is in Z, but -3 is not in N. Okay, and then we have another concept called subset. I'm sure everybody knows what subset means. So if we have a set like A, B, C, and we have another set, let's call this one B. We have another set A, which is B and C. So we would say that A is a subset. A is a subset of B, and what we mean by that is every element of A is also an element of B, right? If you check this, that's in A. Is it in B? Yes, of course. This is the other element of A. Is that in B? Yes. So every element of A is also in B. Therefore, we say A is a subset of B, and we have notation for that. We write A like this, B. That means A is a subset of B. Now, from this definition that I wrote here, that what we mean by subset, we can also see that A is also a subset of itself because every element of A is in A. So by this definition, A is a subset of itself. Okay, so going back to our numeric sets, we had N, we had Z, we had Q, and so what can we say? I think we can say that N is a subset of Z, right? Every natural number is also an integer. And also we can also say that every Z is a subset of Q. We saw, like, for example, 1.5 is in Q, but we also saw that 6 was in Q, and so on. Every element of Z is in Q, so Z is a subset of Q. Okay, now what are the real numbers? The real numbers are denoted by that, but what are they? So we have N is contained in Z, and Z is contained in Q, but we might ask, what was the definition of Q? Q is the set of all numbers that can be expressed as the ratio of A and B. That means A over B, where A is in Z and B is in Z. So we might say, are there any numbers that can't be expressed as the ratio? Can you think of a number that can't be? Like, we already showed that 1.5 it can be expressed as the ratio of 3 and 2, so it's in Q. And can you think of any numbers that cannot be expressed as the ratio? Like, how about, well, I can't even think of any numbers. Like, let's say 1.9876. Well, can that be expressed as a ratio of two integers? Sure, right? You just multiply this by what? By 10,000, I guess. So you get 19876. Did I do that right? 9876 divided by 10,000, and that's equal to these are equal. So this can be expressed as the ratio of this and this. Both of those are integers. So can we think of any numbers which are not rational? So that seems like a good question. Like, how could I? Well, I don't know. I can't think of anything. How about? Okay, so there is an answer. For example, the number pi turns out not to be rational. The number the square root of 2 turns out to be not rational. There are many numbers that are not rational, but the question is, how do we even know that these are not rational? So how do I know, for example, that this is not rational? So that means I have to show that it cannot be expressed as A over B, where A and B are both in z. How do I do that? That means I have to check every possible a and b combination and show that none of them equals the square root of 2. So that's obviously impossible. You can't check every possible a and b. So how could we possibly show that it's not a rational number? That is, how could we show that the square root of 2 is not in Q? How can we do that? Okay, so there's a way to do it. I'm not going to go through it here. You can look it up easily on the internet. It's called a proof by contradiction. So you proof by contradiction. So the idea is, I'll just give you the hint, the basic idea. So you assume that the square root of 2 is rational. Assume that it equals some a and b, where both a and b come from z, and you make a few steps based on that assumption, and you get to something which is impossible. And so you have to say that your original assumption must have been wrong. So that's how it's done. But anyway, we're not going to do that. The point is that there are non-rational numbers.